example today is, so the data we use today is from the VA randomized trial of CABG versus standard medical therapy in patients with stable angina pectoris, and dataset names CABG.SAV. Primary study endpoint is all-cause mortality at 6 years. And this study is in fact is RCT and look at the effect of CABG, although today we are not going to use CABG as exposure variable instead, and we will use clinical risk group of 3 groups, and we compare how its effect on 6-year mortality. Clinical risk groups were based on 4 non-invasive variables measured at baseline: New York Heart Association Class 3 or 4, history of hypertension, history of MI, and ST segment depression on the resting electrocardiogram. And the outcome is death, which is a binary variable, 0, 1. Okay. And the clinical risk is categorized into 3 groups: low risk, moderate, and high risk. And today we are going to assess how clinical risk affect on 6-year survival. Let's do this 2x3 table in SPSS. And this is the clinical risk, and you see a category of 3, 1, 2, 3, and outcome is status 6. 1 is death and 0 is survivors. And to do contingency table, you go to describe and cross tabs. Okay, and we want to put the row as status and column as clinical risk. Okay, and let's click on statistics so that you get p-value for chi-square. See what happened. Since we don't have 2x2, so we are not going to get odds ratio, so we are not clicking risk button here. And it is always better to put percentage here. So let's put the column percent, so you can compute percent of death within each risk group. And go back, cross tabs, and now you click cells, and we want percentage within each column. Okay, and continue. Okay, so 6-year mortality in low risk group is 14.8%, and moderate risk group is 24.6%, and high risk is 35.7%. Okay. And if you want to graphically show this, and you can do chart builder. Okay, so this is if you want to do bar graph, let's do bar. Okay, and put the status 6 on y-axis and clean risk on x-axis. Okay, and then here, and you want to tell SPSS what y-bar will be. So here I'm going to click mean. Okay, because we coded 1 for death and 0 for survivors, so mean will give percent death, and then you click OK. Okay, so it looks like a nice dose response. Okay. So today we are going to put the p-value on this graph and see what we can do. And go back to Spss output. Here. So we computed chi-square test, and p-value is less than 0.001, which is highly significant. And now we have 3 groups. So what do you think this p-value actually means? Are we comparing which group? Okay, so that's the first question. Right? So this chi-square test in fact provides a global test of equality of group proportions. Okay, so what does it mean? The null hypothesis is whether proportion of death is the same across 3 groups. Okay, So this p-value is rejected, less than 0.05. So null hypothesis is rejected. So this means, okay, let's remember ANOVA concept, the same concept as we learned in ANOVA lecture. So rejecting this null hypothesis means at least one group differ from another. And although we don't know there is a difference, so now we are allowed to look at each pairwise. As I said in the cross-tabulation table, since we have 3 groups, so if you want to compute odds ratio and click this risk, this doesn't execute. And this works only when you have 2 groups. So why don't we just use 2 groups? So to select 2 groups out of 3 groups, and you go to Data, select Cases, and click on If condition is satisfied, and click again on this If button, and you specify clean risk not equal 3. Then this will execute group 3. Therefore, you can compare group 1 and group 2. And go back to cross-tabulation table. And now let's run the risk and see if odds ratio is computed. And yes, it did. So odds ratio comparing 6-year mortality between low risk and moderate risk is 1.878 and p-value is 0.007. And you simply have to repeat this 3 times. So go back, Data, select Cases, and this time, and you select, we did 1, 2, and let's do 1, 3, so we deselect 2, right? And then go back to cross-tabulation table and click OK. Right? So low risk versus high risk, odds ratio is 3.19, which is highly significant. Okay, and then you repeat this to exclude, okay, and group 1. So then this will compare moderate versus high risk group. Okay, so odds ratio between moderate versus high risk is 1.7. So this is graphical presentation of what we just saw on the pairwise comparisons. Okay. So low risk versus moderate, and moderate versus high, and low risk versus high risk. And next few slides, I'm going to repeat this analysis using binary logistic regression. So we are no longer using Pearson chi-square test. Okay, the first we have to select all data points. So let's go to select cases and undo this. Okay, so now we go to regression, binary logistic. Outcome is 6-year survival or mortality, and covariate is clean risk. Okay. And clinical risk is now categorical variable. So let's click on categorical box and then put the clean risk under categorical box. And we need to tell SPSS when you do pairwise which group you want to use as a reference category. So I want to compare each group to low risk group. So let's change last to the first. And you need to make sure you click change button. Click on options. Okay. And we need 95% confidence interval. Alright. I think we're ready. Continue and OK. And this is a result of the logistic regression. omnibus test of model coefficient provide a p-value. Okay, and let's look at the p-value for the model. And this p-value or chi-square value 28.35, and this in fact is the same as the likelihood ratio test when you compare three groups used under contingency table. Okay, and likelihood ratio test does a similar thing with Pearson chi-square. An omnibus test with logistic regression actually testing global equivalence, which means whether a proportion of death is the same across all three groups. Okay, so since this is rejected, so you go ahead to look at the pairwise. Let's look at the result of this regression in terms of odds ratio. Okay, so here SPSS gives a little bit confusing output, and it said clean risk is 1 here, but it's actually, this is a category 1 low risk, and this is a 2 moderate, and this is a 3 high risk. And where you don't see any numbers, and this is a category SPS chose as a reference category. So if you look at odds ratio, which is not B, which is exponential B, okay, and 1.878 is odds ratio of comparing moderate group to low risk group. 3.194 is odds ratio comparing high risk to low risk. And then you have a p-value. So both pairwise comparisons are statistically significant. What's missing here? And this table does not provide comparison between category 2 and 3, which is moderate versus a high risk. And if you want to have that pairwise comparison, and you simply go back, okay, and click on categorical box and set reference category to the last category and continue and OK. Oh, I think I did something wrong, so let me go back and redo. See, I forgot to click on change button, so let's make sure this become last. Okay, or default, it doesn't have anything, so that default is always the last category. Continue and OK. So again, this is category 1, 2, 3. And again, SPSS provide a little bit confusing output. So here you don't see any numbers, and this is a reference category. What was the reference we said, which was high risk group, right? And so this is a low risk, and this is a moderate risk. So if you look at the p-value, this p-value compare moderate risk to the high risk, where high risk odds being 1. Okay. So it's a little bit confusing. In order to have a pairwise, you want to compare really high risk to the moderate being a reference category. You need to take inverse of this. Okay. Again, SPSS compute odds ratio where the reference groups odds being 1. So previous analysis we set the reference category to low risk, therefore odds ratios increased from 1 to moderate and high risk. But in this analysis we set high risk as a reference. So SPSS consider odds of dying in high risk being 1. So when you look at low risk and moderate risk group, and the odds ratio is less than 1. Okay, so you have to fix the directionality. To do that, you simply take inverse of odds ratio, and the same for confidence interval. And if you do that, right, and results are actually matching with what we did with contingency table analysis using Pearson chi-square option. and let's make sure. So I got odds ratio is 1.7, moderate versus high risk, and how we can get this from logistic regression output. And you do 1 over 0.588. Let's do that. 1 over 0.588, which is 1.7. Yes, got it. So there is actually a problem when we present data this way. How many p-values did you compute? 1, 2, 3. So you are facing to multiplicity issue. So you may no longer compare your p-value with 0.05. With a Bonferroni, you need to compare with 0.0167. And in fact, we did global test using omnibus test. So you might argue, since global test detected statistical significance, you don't have to adjust wise comparison for multiplicity. And although there are many people still think you have to adjust for multiplicity even when you conducted global test. Anyway, we can absolutely avoid that argument. There is. Let's look at this trend. Do you think there is a trend increasing a dose in exposure, increasing rate of events? Yes, it looks like there is a dose response. So now we could actually do test for linear trend. The test for linear trend means as you draw a straight line here and test if the slope is 0 or not. And if slope is not 0, then you may say there is a linear trend. Let's do test for linear trend using SPSS. And this is very easy. Go back to logistic regression, and then you simply disable categorical option. Okay. So now you consider clean risk is a continuous variable. Variable have a level 1, 2, 3. 1, 2, 3 is a numeric number, not nominal categories. Okay. And now click OK. And this analysis provides you just one p-value for clean risk. And odds ratio is 1.78. What does this mean? And let's remember what we learned in linear regression lecture. The same thing. Okay? And odds of dying increased by 1.783-fold when exposure category, clean risk category increase every 1 unit. So, what that mean? That means clinical risk increase, change from low to moderate, moderate to high, odds of dying increase by 1.78-fold. Here, 1.78-fold. So, when you actually conducted pairwise comparison, odds ratio from low to moderate was 1.88, and moderate to high was 1.7. And this linear trend test and actually average these two odds ratio. So average become 1.78. Okay. So looking at this graph, it seems okay to average these two odds ratio because it's numerically it looks similar. So we draw a straight line and we analyze clean risk category as continuous variable, which is linear trend test. And you need to be very careful. In this data, visually it looks like there is nice linear dose response trend. Although if your data looks like this, and if you conduct linear trend test and you fit straight line and then test simply indicate whether this slope is 0 or not. So based on this, if you say from low to moderate, moderate to high, there is the same increase of odds of dying, then you may reach to a misleading result. So test for linear trend, and first thing you need to make sure visually if there is nice linear dose response, and then you conduct this test, and then you can put the p-value for this straight line.